All right, everyone. So this lesson that you're going to see for Algebra 1 is lesson 2.1. It's titled Kinds of Numbers, okay? Kind of has a weird title. And we are actually going to be starting off on page 46. Now, before you go to page 46 and before we actually really dive into lesson 2.1, I want to emphasize to you guys that last week you were at the end of chapter 1. And before you move on to lesson 2.1, what you need to do is in your textbooks, right? You should be working on page 42 and 43, the chapter 1 review. You are to work on all the questions except for question 40. And this is kind of a review of everything that has been covered throughout chapter 1 or throughout the first 2 weeks that we've been together, okay? After you finish this assignment, this homework assignment, okay? And remember, you can look at notes, you can go back to old homeworks if you need to. But once you finish this, you should be prepared to take the chapter 1 test. So don't move on to lesson 2.1 or 2.2 or anything in chapter 2 until you have completely finished chapter 1, especially the chapter 1 test. Now, the chapter 1 test is due next class, September 10th, and it will be personally sent, you would personally hand it to me in class, okay? Right towards the beginning of class, there's going to be a bin up by where my table is, and you'll be able to put your test there, your chapter 1 test. So mom nor dad nor whoever's with you is grading the assignment. They do, however, need to initial kind of put that they proctored the exam, okay? And I will be grading it and handing it back to you the following Tuesday, September 17th, okay? So just so you know, this is kind of what you need to be doing before you move on to lesson 2.1 and 2.2, okay? But if you have not done so, stop this video, start working on this and the chapter 1 test. If you've already finished all this, then just jump into lesson 2.1, which, as you can see here, I have written down, which are the kinds of numbers. Now, you're going to see me kind of go back and forth with these printed notes, more specifically this Venn diagram looking notes, okay? And I'm going to be emphasizing basically what each part of a number is, or what each part of each kind of number is, okay? So you're going to see me kind of work back and forth with some questions from the textbook, some questions while reflecting back on these printed notes. Just be mindful that that's what I'm going to be doing, okay? So have this out. If you don't have this out, pause the video, get it out now, and you can replay it once you have it, okay? So let's jump into it. Basically, kinds of numbers. There are so many different kinds of numbers, and if you actually look on page 46, you're going to see a bunch of different types of numbers, which are actually just right here on this Venn diagram. Now, the first one that I want to emphasize are natural numbers. Now, whatever I write on these printed notes, feel free to write along as well, okay? If this is what's going to help you, I'm going to try my best to kind of write around this Venn diagram, but not too much, so you're not too confused. But we're going to start off with what a natural number is. This is one type or one kind of number that we can talk about. And a natural number, I'm going to be honest, is the easiest type of number. If you notice, take a look at these, how it says 1, 2, 3, blah, 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 dot, 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 right? That just means that natural numbers are regular numbers. 1, 2, 3, 4, 5, 6, so on and so on and so on, right? I like to say that natural numbers are numbers you naturally count with, okay? And why do I emphasize it like that? Well, when you start counting, if I was to ask you how many chairs are in your house, right? You wouldn't start off with the number 0, then 1. For every chair that you count in your house, you would say 1, then 2, then 3, and so on and so forth, okay? So that's how you can naturally count. It's just basically 1 to infinity. So that's a good point to make, starting from 1 all the way to forever, basically. And that's an infinity sign, by the way. Now, whole numbers, I'm going to be honest, are pretty much like a natural number. The only difference is instead of starting with 1, you're starting with 0. So it's almost the same thing. It's 0 to infinity. And why would this be slightly different? Well, 0, you don't start counting with the number 0. However, whole number represents how many items or objects you have, right? For example, I can say that I have 2 pizzas or 2 whole pizzas. I can say that I have 3 pizzas or 11 pizzas, but I can't really say that I have -5 pizzas, right? However, I could say that I have 0 pizzas, okay? So this is referring to objects or items or real things, but not necessarily counting them, just saying how many you have, okay? Now an integer kind of looks like a whole number and a natural. You have 0, 1, 2, 3, but then now you have -1, -2, -3. That's because integers are just like whole numbers, but they are whole numbers and their opposites. Hopefully you can reflect back on what the word opposite means, but opposite, just to remind you, just means positive and negative numbers. Now, if you notice all throughout this section, right, an integer, and this is a special note that you can write out, an integer, a whole number, and a natural number don't really have any fractions, so no fractions. If I have space to write it, no fractions or decimals, no decimals. However, can each one of these become fractions or decimals? Sure, why not? I can definitely make 1 into a fraction by putting it 1/1. I can make 15 a fraction by putting 15 over 1. I can make -3 a decimal. I could put -3.0. So all of these, even though they are their own thing, they all fall under this main one, which are rational numbers. And that's the important word here. Rational numbers is basically any number that can be written as a fraction. So for example, let's kind of play with numbers. Let's say if I had -2, can I make -2 a fraction? Yep, just put it over 1. How about 0.5? That's a bit tricky. Well, this 5 is in the 10th place, so that's the same thing as saying 5/10. Okay? Even numbers that have repeating decimals, right? So this is something that I'm gonna include in a moment and I'm gonna teach you, but it's not really in your textbook, so this you will find interesting. Something like 0.7 repeating. How can that be written as a decimal, okay? I mean, as a fraction, excuse me. This is a decimal. We'll talk about that in a moment. How about if I had -5? Yep, that can be written as a fraction by putting a 1 at the bottom. So maybe some of you are wondering, how do I make a repeating decimal into a fraction, right? Because rational means everything must be a fraction. So to make a repeating decimal into a fraction, all you would need to do is see what number is being repeated, in this case 7, that goes as your numerator, and anytime you see the repeating bar, you're actually going to represent it as a 9. Yeah, so anytime you have a 9 at the bottom, that means it's repeating. So a great example of this would maybe be like 0.24 repeating. Well, how would that be written as a fraction? Well, 2 and 4 are both repeating, so that goes as your numerator. And your denominator, well, it can't just be a 9, because now we're dealing with 2 digits. So in this case, it's actually going to be a 99. And if I had 3 digits that were repeating, it's a 999. And 4 digits, 9999. But basically, anytime you end with a 9, right, or have 99, 999, that's how you know it's a repeating decimal. It can still be written as a fraction, meaning that it is all rational, okay? So these are good notes to make of this. Rational numbers fall under all of these, right? And naturals are rational, a whole is irrational, an integer is irrational, a decimal is irrational. These are all good ways to see that a rational is just any number written as a fraction. Now, you've heard of rational, but at this very bottom part right here, and I think I'll try to show you, at this bottom part right here, it says irrational. And irrational are just not rational. Kind of seems boring, right? Well, I'm going to break down what an irrational number is actually on the back of this page. So if you can turn over this page, I'll give you the definition of something that's an irrational number. Okay? So I recommend you flip over this diagram, this Venn diagram, so you have the definition of an irrational number. And the definition is basically a decimal, so a decimal that does not repeat, and does not terminate. And you're probably wondering what that means. And I'm going to show you an example of that right now.